Oh, this is Mr. McMurray, and we're in chapter 5. We're really getting some speed now, and we're going to have some momentum hopefully going on in this chapter. So, chapter 5 is all about momentum. Let's go back a little bit. We talked about one time we mentioned, I believe, like a semi truck that's going 60 miles an hour and a semi truck that's parked on the side of the road stopped. Okay, and we asked which one has more inertia. All right, and the correct answer is they both have exactly the same amount of inertia because inertia only depends upon mass. And the mass of the semi truck is the same whether it's going 60 miles an hour or if it is it's parked on the side of the road because that all has to do with mass. But you think that's not right. There's a big difference if I pick a step in front of a truck going 65 miles an hour and one that stopped because I'm going to get splattered all over the place if I step in front of the fast one, okay, the one that's moving. But what we're thinking of is not inertia because inertia does just depend only on mass. What you're thinking of is momentum, and that's what we're going to talk about in this chapter, okay? So in this chapter, we're going to talk about momentum, and momentum is, find anything here, all right? Momentum is basically inertia or mass in motion. All right. And so if you have the semi truck going 65 miles an hour, it's going to have a lot of momentum, whereas the one on the side of the road is going to have no motion, so it has no momentum and therefore is harmless to you. So in terms of which one's going to do damage to you, is we're really talking about momentum, not inertia. Okay. And so momentum is where we're going to talk about that. And so the formula for momentum is P, which is the symbol for momentum, equals m times v. Or another way to look at that is momentum is, oops, not minus, is equal to mass times velocity. Okay, so the amount of momentum you have is going to depend on how much mass you have and how fast you're going. Okay, and that's generally what we tend to think of when we talk about how much damage it's going to do or something like that. Then this is really what we're talking about. All right. And so why the word P? Are they just trying to be difficult or what? And basically, P is the Latin word. This originally was called impetus. In fact, I believe Newton, when he was talking about some of his laws and stuff, called it impetus. If you have no impetus to get out of bed, that means there's no motivating force to get you out of bed. And so they used to call momentum that. And even though they called it momentum, they said, hey, let's go back and use the P. I guess you already had M for mass and whatever. So they decided, hey, big M means mega or million, something like a megameter or megabytes. So they said, hey, let's just go back and let's use a P. Does it make sense? It makes it a little complicated sometimes, but deal with it and move on. All right? Okay, so here we go. Momentum is a vector quantity. If you remember, velocity is a vector quantity. So since velocity is part of momentum, that means it will also be a vector quantity. And remember, once again, vector quantity only means that it has a direction. Okay, it's a magnitude, which is a scalar, like 35 degrees is a scalar thing, but there's no direction to degrees, so it's not a vector. Velocity is how fast it's going, but it's also going to have a direction. So the momentum will have a direction, okay, and that can be very important, especially when two objects hit each other. It depends on what directions they're going, what will happen when they hit. Okay, so it is a vector quantity. Now, so, and as we said, kind of basically roughly already, I think, but let's go over it again. Basically, if you want to have the amount of momentum something has, it can depend on two things. One, it can depend on the mass. This is an oil tanker. Oil tankers are extremely large. I don't know how many football fields long, but very, very large ships full of oil. It's going to have an extremely large mass, okay? And when they're coming into port, they will actually turn off the engines, 25, 30 miles out and completely coast all the way in because they have so much momentum they're not going to be able to stop if they wait later to turn off the engines. So they'll actually turn it off 25, their momentum will carry them in, and by the time they get to the dock, it's low enough momentum that and their velocity is so low that it's easy to stop them and then maneuver them around to dock. And so it has an extremely large mass, okay? And if it has a good velocity, then that's a lot of momentum, and it takes a long time to get rid of that. Okay, so if an object has a large mass, it doesn't have to be going very fast to have a large momentum. The other thing is its speed. The faster it's going, the more momentum it has. All right, a bullet, for example, is fairly small mass, but it's going to be going very, very fast, and so it can still have a fairly large momentum compared to a lot of other things because it has a lot of speed, even though it doesn't have much mass. Okay, obviously, if you have both mass and speed, like this oil tanker going at top speed, then you're going to have a really lot of momentum. But that's the two things: basically, how big is the object and how fast is it going. When we talk about changes in momentum, we start seeing the connections between momentum and Newton's laws that we talked about with forces and acceleration and so forth. Kind of ties back into that. Okay, in order for the momentum of an object to change, either its mass has to change or its velocity. Generally, which one's going to change? Well, it's more likely the velocity is going to change. An object going down the street, say a truck going down the street, it's usually not going to change its mass. Granted, something could fall from a tree and land in the bed of the pickup truck, and now it has more mass. But generally speaking, it's not going to drastically change its mass all of a sudden. What is going to change is its velocity. It can either speed up or slow down or change direction, and that would result in a change in its momentum. Now, in order to change the velocity, and changing the velocity is called, that's right, acceleration. So to cause it to accelerate, you have to have some type of force. Okay, and so generally a change in momentum is going to be caused by a change in force. Okay, and the bigger the force is, then the bigger the change in its velocity, or the greater its acceleration. Remember, that could be speeding up or slowing down or changing direction, but it's going to do that even more so if you have a greater force acting on it. Okay, and so the greater the change in velocity, you're going to have a greater change in momentum. Okay, and there's a formula that tells us how much of a difference is it going to make. All right, let's type something here. All right, the force acting on an object is going to be something called, has to do with something called impulse. Okay, and impulse is equal to the amount of force, not farce. Okay, let's try that again. Force times the time that the force is applied. So the two things that are going to affect how much force there is and how much the force changes the momentum, I should say, all right, is going to be how much force is there. The more force you have, then it's going to have a bigger effect on the momentum because it's going to change the velocity or change its acceleration a lot. Okay, we learned that in Newton's second law. It also, though, has to do with how much time that the force is applied. If the force is applied for a short length of time, that's not going to change the acceleration or momentum as much as it would if it's for a long period of time. Okay, and so the force times the time is known as the impulse. Okay, and this impulse is going to determine how much of a change in momentum there is. So if we're talking about the change of momentum, it's going to be determined by the impulse. So another way to say that simply is to say that the impulse is going to be equal to the change in momentum. All right, and so the greater the impulse, the greater the momentum is going to change. The less the impulse, the less the momentum is going to change. All right, if we wanted to put that into formula form and write it in terms of formula, that would mean the impulse, which is the amount of force, times the amount of time, which is the change in time, or delta t, all right, is going to be equal to the change in momentum, which is going to be the mass basically times the change in velocity, because that usually the velocity is what's going to change. Okay, so we take the amount of force times how long the force is used, the time, it's going to be equal to the mass times the change in velocity, which is the change in momentum. So the bigger the impulse, the more change in momentum there will be, the more longer time we apply the force, there will also be a bigger change in the momentum, known as the impulse momentum relationship. In other words, these two are related according to this formula. If you increase the force, it's going to increase the change in momentum. If you increase the time that you apply the force, that's going to increase the change in momentum also. So that is known as the impulse momentum relationship. All right. Now let's look at some ways that we can change impulse and momentum and how they affect each other if we do that. A lot of times we want to increase the momentum. Okay. And there's several different ways we can do that. Okay, the first obvious thing is if we increase the force. If you're a baseball player and you want to hit the ball farther, give the ball more momentum when you're batting, then basically the harder you can hit the ball, the more force you exert on the ball, then the ball is going to have a bigger change in momentum and it's going to go farther. Okay, because you changed its velocity, not its mass, but you changed its velocity enough that it's going to go a lot farther. So the easiest way then is just simply to increase force, and that's pretty much pretty straightforward.